Welcome to a sim code like what you see. Hit like, subscribe, and be part of this coding adventure. Shell sort in C is an efficient algorithm that improves upon the basic insertion sort by comparing elements that are initially far apart, reducing the number of comparisons and shifts needed to sort the array. The algorithm starts by selecting a gap, typically half the size of the array, and compares elements that are gap positions apart. This allows for larger elements to be moved closer to their correct position early in the process, reducing the number of shifts in later passes. After each pass, the gap is halved, and the algorithm continues to sort the array with progressively smaller gaps until the gap becomes 1, which then performs the final pass similar to a regular insertion sort. The time complexity of shell sort is dependent on the gap sequence used, and while it's generally faster than insertion sort, it is still not as efficient as more advanced algorithms like quicksort or merge sort for large datasets. The key benefit of shell sort is that it provides a significant speedup over insertion sort in practice for moderately sized arrays. Function to perform the shell sort algorithm. Shell sort overview. Shell sort improves upon insertion sort by comparing elements that are further apart. This reduces the total number of comparisons and shifts needed. Initialization. Gap is initialized as half of the array size, n/2. This controls the distance between elements to compare and move. Main sorting logic. Outer loop continues until gap becomes 0. After each pass, the gap is halved. Inner loop processes the array by comparing and shifting elements that are gap apart using a modified insertion sort approach. Insertion sort logic. Elements are shifted if they are larger than the current element, temp, allowing the array to get sorted progressively. Gap reduction. After every pass, gap is halved. Bringing elements closer together until the gap is 0. Printing the array. The array is printed after each gap pass to visualize the progress of sorting. The final sorted array is printed after all passes are completed. Initialize gap as half the size of the array. Outer loop continues until gap becomes 0, having the gap after each pass. Loop through the array starting from index gap to n to perform sorting for current gap size. Perform insertion sort for elements that are gap apart. Shift larger elements to the right. Move J back by gap distance. Place the element at the correct position. Print array after each pass to show sorting progress. Have the gap after each pass. Function to print the final sorted array. Main function to demonstrate shell sort. Example array to sort. Calculate the size of the array. Print the original array. Perform shell sort. Print the sorted array. Conclusion: shell sort improves upon insertion sort by initially using larger gaps, making sorting faster. The gap reduction ensures efficient sorting as the array gets closer to being fully sorted. Now run our code. That's all for today. Please like, comment, and subscribe to see more.